Hi, and welcome to CCNA 2. We're going to start with Module 1. We're going to jump right into it with basic device configuration. You should be familiar with a lot of this. This really should be review for you guys. So we're going to talk about stuff like initial settings for switches, configuring switch ports, remote access like SSH or Telnet, hopefully SSH, some basic router configuration, and we're going to talk about some verification of these connected devices. So for that, we'll use stuff like LLDP or CDP. Oops. So in this video, we're going to go over the initial switch settings, and then in each video, we'll go over the next portions. So with DRAM, DRAM is what we think of as RAM. Now, this is something that's really confusing to a lot of people who are new to IT, is this idea of memory. Now, yes, you have memory in different types. There are many different types of memory, but if someone just says memory, they usually, if they know what they're talking about, they should be referring to DRAM, which is commonly referred to as RAM, right? So this is super, super fast stuff. This is where your processor is going to keep the files it's working on. So for example, if you open an Excel spreadsheet, if you open a PowerPoint presentation, that PowerPoint presentation is going to go from your flash memory on your computer, not maybe flash, it may be an old school hard drive. Either way, it'll come from your storage and it will go into your memory. And the memory is much, much faster than your storage, so the CPU can communicate with it very, very fast. That's the purpose of DRAM. Now keep in mind, the one thing we want to remember the most about DRAM is that it's what's called non-volatile, which means that RAM, whenever you lose power, so whether it's on purpose, whether you shut down the machine, or whether you have a power outage of some sort, or some other kind of power failure, maybe a power supply goes out, all of the information in RAM is going to cease to exist. It's going to be gone. Whereas all of these other types are all going to keep that memory, that information between boots. So you have read-only memory, which never changes. Now some of the newer manufacturers of I shouldn't say newer manufacturers, but the newer I can't think of the word, motherboards will actually define things as ROM when technically they're not read-only memory. They may serve the same purpose, but they can have updates and other things that wouldn't have been possible in the past with ROMs. But for the sake of this course, ROMs never change. And they contain stuff like the bootstrap and the power on self-test post. You should be familiar with that if you've done any kind of IT stuff before, maybe like an A+ certification, or maybe you have an entry-level job or something like that. You should be familiar with post. So the read-only memory, that's what never changes. That's the very, very beginning part. This really is going to just go and find something in Flash to boot up. So Flash is what's going to contain our iOS images. It's going to contain, we can put other files in there if we want. Sometimes we'll have a backup iOS image. So for example, a lot of times network administrators, they like to, when they update an iOS image, they like to put a new one on, but keep the old one just in case they need to revert back. Very, very smart practice. Always have a backup plan. Whether now you can have that iOS image on a file server somewhere as a backup, but a lot of times it's real nicer if it's on the device itself. And then the NVRAM. Now, the one thing really that we save NVRAM, and I know my camera's covering it there, but NVRAM stands for non-volatile RAM, which means, of course, it does not lose memory if it loses power. It's going to contain our config files. It's going to contain our startup config. It's going to contain maybe any backup configs we have. A lot of times there's other things that can be put on here if we need to throw something onto a switch or router. So with the boot sequence, we're going to have these 5 steps that we're going to take when we power on our switch. So first, it's going to do the post, right? The power on self-test, very, very important. And this comes from our ROM, right? The post is going to check CPU, it's going to check RAM, and portion of the flash to make sure that, hey, basic functionality is working, right? Our normal bare minimum stuff is working. So if it's not for some reason, we can troubleshoot, figure it out from there without trying to load the iOS and having all kinds of weird reactions if there's something with the core system that's having an issue. Then we're going to go into the bootloader software. So this is going to really just run immediately after post. It's stored in ROM. It's going to initialize some of our hardware, like our CPU, controlling where the memory is mapped itself, how much memory we have, etc. And then the bootloader, again, right, same thing, bootloader here and the bootloader here, is going to initialize flash. And then we're going to use the bootloader again to locate the iOS operating system that we set, hopefully, or maybe it's the default before we set it ourselves. But it's going to find that iOS image and it's going to load that. And once that happens, the iOS image is actually going to go into the NVRAM and go find a configuration file. So the boot system command is really going to tell that bootloader what iOS image we want it to load first. So if we don't set this variable, it attempts to load the executable in the first executable file it can find. This could be bad. Maybe we have, like I mentioned before, 2 different versions of iOS on a switch. It might load up the older version or the newer version, and that might be a mistake. So we want to be really careful and make sure we update this and keep it up to date whenever we make a change here. So once we actually have the iOS initialized, it's going to look for a startup config in NVRAM. If it doesn't find one, it's just going to load up. You guys should have seen this before, right? We're in CCNA 2. It's just going to load up and ask if you want to go through some prompts maybe, or it's just going to load up with a blank configuration. So we can use the show boot command to see what the current file is set to. If we don't know, maybe we just got hired in a new organization, and we can always change it with this boot system command. Now notice it's in configuration mode, and I almost want to say that is a typo. I thought for some reason it was not in configuration mode. I thought it was in privileged exec mode. We can test this live. I'll got a switch here, and it looks like I was wrong, and I can make this bigger so you guys can see it. Oh, where's the change settings? There it is. Change the font size here to something a little larger. Maybe you guys can see here. So I tried to do the boot system command here in privileged exec mode. That didn't seem to work. So I'm going to try it here. And of course, that is correct. So the screenshot is actually correct. I do this because I do find errors in the curriculum more often than I wish I did. So that's good. So you do put it in the configuration mode. And of course, boot system is the main command. The flash is a storage device, which is pretty much always flash. It should be. And then we may have a folder. If we have a folder, we'll need to put it in there. And of course, with a /, and then the actual file name. Now in production, I usually see that there aren't any folders. There's really no reason unless you have a ton of files in your flash, which you shouldn't have that. So usually it's pretty standard. Just have everything in your in VRAM. So I want to mention when you hit that command copy run start, or if you're a super hacker like me, use that old school command WR, um, which you're not supposed to. So if it asks you on the test, go copy run start. Don't do the WR on the test. But in the real world, WR works great. It's a lot easier to type than that. So there's two things that are going to happen when we run this command. The startup config is going to be created or overwritten. And then there's going to be a file named config.txt, which is really just a link to startup config in NVRAM. So you can verify this by going into a switch and going to the directory and typing these commands. And we can actually do this live. Nope, didn't mean to Google Putty. Why is it not? There it is. So then I'm going to hit change settings and I'm going to grab the why am I total appearance? Get at large and then I'll go logging over here. So, let me do a dir command. I'll see everything in our flash directory. So as you can see here, we have read-write and execute commands, permissions, I should say. This is very similar to Linux, read, write, execute command, keep saying commands, permissions on all these files. You'll see there is a config.txt. There is no startup config because we're in Flash, not in VRAM. You'll see there's a VLAN.dat, which we'll talk about when we get to VLANs. You'll see I actually have a backup, two different backup configs here, which I know these dates are definitely wrong, but that's fine. There is another backup here that I called private config. And here we have our iOS image. You'll notice this is a relatively old iOS image that I have on this switch. What I can also do is, if I could spell right, I think I need a colon here. Yep. So I'll have to fix those slides. I need a colon, and you'll see here that I also have startup config. There it is. I also have some other stuff, some configs thrown in here. Here are some certificates. So you'll need these if you're running SSH. You'll need some certificates. In this case, they're self-signed because this is not in production and we're not worried about certificates here. And I'll throw this over here because I swear I'll want to do a demonstration again. So these LEDs are very important when we're starting to have issues. If we can't, for some reason, get into the console, we can use these LEDs. And sometimes if you're there in person, it might just be easier. So really, the system LED really shows if we're receiving power, right? If it's turning on, this will usually blink if it's turning on, and it'll be green when it's on. We're going to power supply LED. Now, this is not on every single switch because not all switches have redundant power supplies, but it might be there. Of course, it'll tell you the redundant power supply status, the power status or port status LED, which this is on the port itself, which will tell you based on the mode selected some different information. So you'll see here we have status, duplex, speed, and PoE. These are all different modes. You can hit this button and it'll cycle through, right? So if we have an import duplex mode, when the port is green, it indicates duplex mode is selected. This duplex light here is green. Then we can understand the light associated with each port, right? So then, depending on which one is selected here. Say, for instance, status. If status is selected here, then all of the ports interfaces, because each port has an interface. Each port has an LED, excuse me. Each one of those will reflect the status of that port. Now, if we hit this mode button again, then it's going to show the duplex information of that port in LED, depending on what the options are: green, orange, red, typically. Speed, next time we hit mode, it'll go to speed, so you'll be able to see if the speed negotiated is a gig, is 100 meg, etc. Depending on your switch type, it might be different. And then, of course, the PoE status. So this is very, very useful if you're dealing with PoE devices and you're trying to figure out, hey, is the switch delivering PoE to this port? If not, then we can go with that information. So very useful. Let me clear that. So here's a big sheet that'll show you all the different colors and what they mean depending on the mode you're in. Right here's all the modes. Here's if the LED's off, if it's green, if it's blinking, if it's amber, if it's blinking amber, etc., etc. And you can look at that if you'd like. A helpful reference if you're troubleshooting an issue, but easily you can easily find it on the internet. Now, the bootloader is going to provide access to the switch if the OS cannot be used. So if for some reason we can't boot into iOS, we can go into the bootloader itself. And so I will not show you this on a live switch, but we can connect with a console cable. Of course, we need to configure the terminal emulation, right? So if you're not familiar with that, but in default, it's all the right stuff for Cisco. So you can just go download PuTTY or TerraTerm or Secure CRT, or if you're on Linux, you don't need to download anything. Then you can unplug the switch, reconnect, wait 15 seconds, press and hold the mode button. And so what this will do is it'll put it into Ramon mode. You'll get the bootloader switch prompt. Not Ramon mode, the bootloader mode. I don't know why I said Ramon. So you can do a couple things. You can modify flash file systems. I think you can FTP. You can use the dir command to see the files. There's a few things you can do. And there's plenty of documentation that goes into the details of how to go and recover if you're in a situation like that. So say we want to actually not have this situation here. We have to plug in this nasty console cable, right? This is what we're used to so far for the most part. We want to be able to access it remotely. We want to be sitting at home when we get a phone call. We don't want to have to drive into the office. We want to just remotely connect to our routers and switches. So the first thing we need to do is obviously set an IP address and subnet mask to the switch, right? And so we'll do that on the switch virtual interface, or SVI. So, and what that looks like in the switch itself is interface VLAN 1, typically for lab situations, and for now. Now, when you get in the real world, this number will change drastically. It won't be 1. It shouldn't be 1. It could be 100. It could be 1,000. It could be 2568 or whatever. And that's really up to your organization. So one thing to mention, the SVI is a virtual interface and is not a physical port. So when I say that, imagine a port that is connected inside of the switch that you can't see. That's kind of how I envision that, right? It's connected to the backplane directly. It's there, but it's not really visible. It's not really tangible, but it's there. It's an interface, but it's not a port. So they say all ports are assigned to VLAN 1 by default. It's not best practice to configure the management as VLAN 1. So for this example, they'll use VLAN 99. Switch may need to be configured for IPv6 if you're doing IPv6 stuff. You may need this command on like 2960s. I don't think we need that anywhere in this course, but just keep in mind in the real world you might need that on a specific switch if you're trying to enable IPv6 for the first time. So here are the commands we would use. We go into our configuration mode course. We go into the interface of the VLAN, right? This is our SVI. Then we'll go and give it an IP address with a subnet mask, just like we would any physical interface on maybe a router. Maybe you want to give it an IPv6 address. Maybe you don't. Of course, don't forget this no shutdown command. We need that. Now, sometimes I find it's not always straightforward with switches. So sometimes you need it, sometimes you don't. I live by the mentality of I'd rather type it and waste 3 seconds by typing no shut than not type it and then have to deal with troubleshooting it later. So I usually just type it. And then, of course, N to get out of there. And then we have to, of course, save our configuration. If we don't save it, then the switch will reboot and we'll lose all of that at some point. Of course, usually you also need a default gateway. So if you are traversing a router, so say for instance, you're remoting in from home, you're remoting in from another side of a router, you need to do this. Now, 99 times out of 100, you'll need to do this unless you have very, very stringent security requirements on doing this, which I don't think a lot of you are going to experience much, if at all. So keep in mind that we receive this information, the default gateway information, in IPv6 automatically, so we don't need to worry about a default gateway for IPv6. However, for IPv4, we need this IP default gateway command here. So this will tell us how to get off of our network and onto another network. And then, of course, copy, run, start. We want to make sure we save that configuration. Then, of course, we can verify it with the show IP interface brief. Now, keep in mind, this is really a quote-unquote router command because it has to do with layer 3 information, but it can be ran on a switch as well. And if you have virtual interfaces, SVIs, you will see the information associated with them. Now, you'll see here that status and protocol are down. And if you want, you can take a second, you can think, why would the status and protocol of this interface be down? Kind of think through that, maybe some reasons why. Feel free to pause the video if you'd like. Now, one thing to notice here is it does not say administratively down. If it said administratively down, there would be something else wrong. If it said administratively down, we would need to go use that command, right? No shut. Now, it doesn't say that. It just says down, which means we already did the no shut command. That is working just fine, but something else isn't working. And what this means when it has status protocol just down is that there's no interface, physical interface associated with this VLAN. And so there's no reason to communicate with anything because there's nothing to communicate. There either has to be a physical port assigned to that VLAN or a trunk that has the VLAN on it. And so more than likely we would add this VLAN to a trunk that goes upstream to where we could manage it from. Very important note there. So that's it for 1.1. This video ran a little long. I hope to keep them a little shorter in the future, but I will see you in the next video for 1.2.